All right, let's take a look at examples. So this one, we're going to look at a cardioid that's given by this polar equation of r equals 1 plus sine theta. And we want to find the slope of the tangent line when the angle is pi over 3. So what we're going to need to do, we just looked at that our slope here, dy dx in Cartesian form is going to be equal to our dy d theta over dx d theta. So we need to know what is dy d theta and dx d theta. Well, we've looked at that x is equal to r cosine theta, and that y is equal to r sine theta. So what we're going to do is find the derivative of those. But first, we're going to need to substitute in what r is equal to in this one. R is equal to this. So let's plug that value in for r here. Let's also plug that value in for r here. So now we have that x equals 1 plus sine theta times cosine theta here. And over here we got y equals 1 plus sine theta times sine theta. All right, so what we're going to do next now, what is this derivative going to be? So we want to find what is dx d theta here. So that would be the derivative of this. But if you look at that right side, we're going to need to use product rule in order to do this because we got two functions being multiplied. So we'll take the first one times derivative of the second. So derivative of cosine is negative sine plus, now we switch them around, so cosine times derivative of 1 plus sine. Well, derivative of 1 is 0, derivative of sine is cosine theta. So that would be our dx d theta. Let's do the same thing over here now and find dy d theta. Looks like here we're also going to have to do some product rules. You got first one times derivative of that second one, derivative of sine is cosine, plus, now we got to switch them around, so sine theta times derivative of what's in parentheses there. So derivative of 1 is 0 again, derivative of sine is cosine. So there's our two derivatives. So now we're going to put it in to our parametric form here to find that derivative. So dy dx is equal to our dy d theta over our dx d theta, and we know what both of those are. We just found them. And so this is going to be equal to dy d theta is all this. So we got 1 plus sine theta times cosine theta. Okay, so it's this one over the other one we just found. So dx d theta is this one. Now what they want us to do is find what is this going to be equal to when the angle is pi over 3. So everywhere we have a theta now, we want to plug in pi over 3. So what we're looking at finding now is what is dy dx when theta is equal to pi over 3. Now this is a good example of one on a AP test. You may have a question like this that you would have to solve without a calculator. So you should be comfortable enough solving these out if a calculator is not available. Pi over 3 is the same as 60 degrees. So one way you could figure this out, if you remember that little hand trick we had with trig, if you have our angles here, 0, 30, 45, 60, and 90. If we're doing 60 degrees and you put that finger down, the number of fingers to the left is your cosine value, your value here where you put the number of fingers in that square root. So this would be square root 1 over 2. And the number of fingers to the right is your y value. That'd be square root 3 over 2. So what that's telling us here, if you simplify down, is that square root of 1 is just the same as 1, so that's telling us that cosine of pi over 3 is equal to 1/2, because that's our value here, and then that sine of pi over 3 is equal to square root 3 over 2. That's the second value here. So let's see what this evaluates to now. So add pi over, or any sine value then is going to turn into square root of 3 over 2. So this is going to end up being 1 plus sine of 3 pi over 2 is going to, or sine of pi over 3 is going to be square root of 3 over 2. The cosine value is going to be half. Here, sine, again, is square root of 3 over 2, and cosine value is half. On bottom here, we're going to end up with 1 plus square root of 3 over 2. This is negative sign, so that's going to turn out to be negative square root of 3 over 2. Plus, and both of these are going to end up being half. So now let's see if we can simplify all this down and see what we get. It looks like here we're going to have to distribute. Same thing here, we're going to have to distribute. So we get 1/2 plus square root 3 over 4 plus square root 3 over 4. On the bottom, we're going to have negative square root 3 over 2 minus, sorry, we're multiplying these two together now. Square root 3 times square root 3 is just going to be 3, and 2 times 2 is going to be 4, plus half times a half is going to be a fourth. So let's continue to simplify here to find our slope. We have some like terms that we could combine together on this one. So these two being like terms and these two being like terms. So let's add that up. So now you got 1/2 plus square root 3 over 4 plus another square root 3 over 4 would be 2 square roots of 3 over 4. On bottom here, we're going to have negative square root 3 over 2. And then here, adding those up, negative 3/4 plus a fourth is going to be negative 2/4. We can do a little bit of simplifying here. 2 goes into 4 2 times, 2 goes into 4 2 times. So we get 1/2 plus square root 3 over 2. On bottom we got, we'll write this as negative 1/2 minus square root 3 over 2. Now, it doesn't maybe look like that can simplify any further, but we can if we factor a negative out of that bottom. What that's going to make this is 1/2 plus square root 3 over 2. And notice that's the exact same as the top now, so these cancel. So it looks like our slope, if that cancels, would just be negative 1. So that would be, that's our slope of the polar curve when the angle is pi over 3. If you go back to the picture here, just to give you a visual of what we just found, pi over 3, so here's 0, there's pi over 2, pi over 3 is probably somewhere in there. So what that's telling us is the tangent slope there is, that slope is negative 1 when this angle right here is pi over 3. Okay, so that gives you kind of a visual there of what's going on. All right, let's go on the same problem here. Now in this part B, they want us to find the points on this cardioid where the tangent line is horizontal or vertical. Well, we came up with that derivative on the last problem. So we're going to look at using the same derivative here. see if we can cap. All right, so I've copied and pasted over from our part A, the slope here. So our where the tangent line is going to be horizontal, we know that's anywhere that our slope here, dy dx, is equal to 0. So on our what that means here is if we want to find where it's horizontal, that's where the slope that we just found right here, that's where the numerator would be equal to 0. So what we want to do here is take that numerator, set it equal to 0, and solve it out. So if we put that numerator equal to 0 here, that's going to be 1 plus sine theta cosine theta plus sine theta cosine theta equals 0. So let's see if we can solve this out here. So first thing I notice, both of these do have a cosine here. So let's see if we can factor out that cosine to start with. So I'm going to factor that out, cosine theta. What would be left then is 1 plus sine theta from that first term plus another sine theta from that second term equal to 0. That can be simplified to sine theta plus sine theta is 2 sine theta. All right, when two things are being multiplied and they're equal to 0, that means one or both needs to be equal to 0. So we're going to set cosine theta equal to 0. And we're also going to set 1 plus 2 sine theta equal to 0. And if we solve those, that should tell us the places where this numerator is going to be equal to 0. To solve that, we could do inverse here. So we can see like cosine inverse equals cosine inverse of what equals 0, and you can solve it that way if calculator's available. Otherwise, think on your unit circle, where is cosine equal to 0? And that's, remember, cosines are x value on the unit circle. So when on the unit circle do we have an x value of 0? That would be right here, and also right here, because this is the point 0, 1, and this is the point 0, negative 1. And so the values that we're going to get for this one would be 90 degrees, which is pi over 2, and 270, which is the same as 3 pi over 2. If we're going to solve this other one, let's minus the 1 over, divide by 2. So here we want to know where is sine equal to negative 1/2. Again, to solve this, if you got calculator available, you could do where's sine inverse of negative 1/2, and you could find it that way. Otherwise, again, think of unit circle. When are we going to get a y value that's equal to negative 1/2? Well, if it's a y value, this is a y value and it's negative, then we know it's got to be somewhere in quadrant 3 or quadrant 4 here where our answer is going to be. So it's one of those two when we solve that out. And to get one of them, you could definitely do calculator here. So let's use our calculator. Otherwise, if you didn't, you'd have to think of the right triangles in there. But if we do this, negative 0.5, we get that. Remember, pi is part of this, so I'm going to divide out the pi. And if I do this as a fraction, looks like negative pi over 6 is the angle, which is right here. This would be negative pi over 6. In terms of positive angles, angles that would be between 0 and 360. If we go around the circle the other way, that same angle would be 11 pi over 6, because you take pi over 6 and subtract from 2 pi. So one possible answer here for this one would be that the angle is 11 pi over 6. The same angle in quadrant 3 should give us the same thing. So if we have an angle pi over 6 here, that would be it. So if we took pi, which is 180, plus pi over 6, we'd get the other one, which would be 7 pi over 6. So those would be the two angles there. So we got the horizontal ones. They also, though, wanted where is our vertical tangent lines. That's when the derivative here, dy dx, is undefined slope, vertical. Okay, and how we're going to find that is take this denominator right here and set the denominator equal to 0. So in order to do this one, we're going to, for vertical, that's where denominator equals 0. So we're going to set our denominator equal to 0 there and solve. So our denominator, what we had there was that we got 1 plus sine theta times negative sine theta plus cosine theta times another cosine theta. And then we want to set that equal to 0. That's our denominator equal to 0. Now let's see if we can simplify this one. There is nothing the same on both sides that we can factor out in the last one, but I see we can distribute here, so let's do that. These are also like terms. Let's put those together. So then we'd have negative sine theta. If I multiply to the other one, it'd be minus sine squared theta. And then cosine times cosine is cosine squared theta. Still equal to 0 here. Next, I don't see anything we can do. Sometimes when you have sine squared plus cosine squared, you put that equal to 1, but this is a negative sine squared, so that won't work. So what we're going to have to do here, let's use that that property we just talked about, that cosine squared theta plus sine squared theta is equal to 1. If we solve that for cosine squared theta, that tells us cosine squared theta is equal to 1 minus sine squared theta. I'm going to put that and replace it here. So now I got negative sine theta minus sine squared theta plus 1 plus sine squared theta. And what's going to happen here now is these two terms cancel, and we're left with oh, sorry, no, it doesn't cancel out. I had should be minus. I wrote it incorrectly here. This should be minus. Okay, so they don't cancel out, but we can combine some like terms here. This is a like term and that's a like term. And so we got negative 2 sine squared theta minus a sine theta plus 1 equals 0. We could probably do some solving with that. I don't like it, though, that term is negative, so I'm going to divide all these by a negative 1, which is fine as long as we divide everything by negative 1. That'll make this positive 2 sine squared theta plus sine theta minus 1 equals 0 divided by anything, still 0. This is now factorable. We can factor this one into two terms here. And so this would be a 2 sine theta times a sine theta. Now we got to figure out, well, how do we multiply to negative 1? It's got to be a plus 1 minus 1. So we want to put it in here so that that middle term ends up being positive. Let's try it this way. If we did that and multiplied these two, it would be negative 2 sine theta we multiplied the inside ones, we'd get 1 sine theta. Does that add up to positive 1? No, it adds up to negative 1. So it looks like we want to switch those signs around here, and then we should have it factored correctly. So we'll make this one negative, this one positive. So now it's factored correctly. So same thing now, two things are being multiplied to equal 0. Let's put them both equal to 0 and solve them. And so if we solve this one, we get that sine theta. We add 1, divide by 2 is going to be equal to a half. So where's sine equal to a half? Again, you can do inverse to solve that, or use the right triangles with unit circle. But that should come out that it's 30 degrees if you do the inverse, which is the same as pi over 6. And so the other place where sine, which is our y value, is positive would be our first quadrant here, and also quadrant 2, our y value should also be positive. So that same 30-degree angle subtracted from 180 would be 150, and if you change 150 into radians, the other one should be 5 pi over 6. Solving this other one, sine theta equals negative 1. Sine is our y value again. There is only one spot on unit circle where you get a y value of negative 1. That's right here, and that would be at 270 degrees, or 3 pi over 2. All right, so final thing now, let's list out what we got there. Looks like we got these angles where it equals 0, and then on the bottom we got these angles. Now one thing that shows up, this one, 3 pi over 2, did show up on both our lists. So we got to be careful there, because if both top and bottom of this both are 0, that's indeterminate form. So you would have to check this one by going through, and you could use like L'Hopital's rule to see what that derivative actually came out to be. If we look back at our picture though, 3 pi over 2 is when we hit this spot, and we can see that that's a point. There's not going to be a derivative there. So that one actually is not going to be part of either list there, because we do not have a derivative at the angle of 3 pi over 2. So this one we should cross off both our lists. So it's going to be equal to, or we're going to get horizontal at pi over 2, and 7 pi over 6, and 11 pi over 6. And then we're going to have vertical tangents at pi over 6, 5 pi over 6. Again, this one is not one because that's where we do not have a derivative.